Welcome back. As always, make sure to subscribe to my channel for more chemistry videos, and definitely check out the video right before this where we go through the rules to Lewis structures and go over some basic examples. So the purpose of this video is to go into a little bit more complicated examples where we have multiple bonds or multiple central atoms. So we're going to keep using this list that we went through before, and the next structure we'll look at is CO2. So remember, the first step is to determine the total number of valence electrons, and that comes from the periodic table, where carbon is going to have 4 valence electrons and oxygen will have 6 valence electrons. Okay, so carbon 4 and oxygen 6. And remember, we had to multiply the number of valence electrons times the number of atoms that we have in the formula. And the carbon, it's assumed to be 1, and oxygen, we have 2 atoms. So we've got to multiply that carbon by 1 and the oxygen by 2 atoms. So we get 4 from carbon, 12 from oxygen, for a total of 16 valence electrons. Okay, once we have the total number of valence electrons, then we had to determine the central atom. And remember that that's going to be the lowest left atom of the periodic table. And looking at carbon versus oxygen, carbon is farther to the left than oxygen, and therefore your central atom. And then we wanted to surround that carbon with oxygens. And so I'm going to place 2 oxygens on either side of that carbon. And the reason why I'm doing it like this instead of clockwise is because carbon doesn't have any lone pairs. And so when I only have 2 atoms, it is best to place them on opposite sides when I don't have any lone pairs on that central atom. Now the next step was to form single bonds from the central atom to the outer atoms. Okay, so I'm going to place a single bond between that carbon and each oxygen atom. And then I was told to distribute remaining electrons as lone pairs on the outer atoms. And remember that looking at that table, oxygen, which are our outer atoms here, those should have 2 lone pairs. Okay, so I'm going to add 2 lone pairs to each oxygen atom, and it doesn't particularly matter where you add them, as long as it's not between where the line is. Okay, so I've added my lone pairs, and then typically I would add any remaining electrons to the carbon, but carbon should not have any lone pairs based on that table. So remember, carbon here should have 4 bonds and 0 lone pairs. So I have added my single bonds, I've added my lone pairs to the outer atoms, no more to the central atom, and then if I check the number of valence electrons that I've used, it's 2, 4, 6, 8, 10, 12. Well, that 12 does not match the 16 that we started with. So we have 4 more valence electrons that we haven't used. And if you noticed, the number of bonds for carbon should be 4, and for oxygen it should be 2. And we don't have 4 bonds to carbon, and we don't have 2 bonds to each oxygen. So something is weird compared to our past structures. We have extra valence electrons, and we don't have the correct number of bonds for each atom. So at this point, what we're going to do is create what we call a double bond. So when we look at multiple bonds, a double bond is going to be represented by 2 lines. And there is such a thing as a triple bond represented by 3. But for this structure, we still have 4 valence electrons, and we know that each oxygen wants 2 bonds. So if I redraw this carbon and instead give each oxygen 2 bonds by doing a double bond, now the carbon is surrounded by a total of 4 bonds. We've got the 2 on the left and the 2 on the right. So carbon now has a total of 4 bonds around it, and each oxygen has 2 bonds to it. And so now we are happy with the correct number of bonds, and if we place the lone pairs back on those oxygens, the 2 lone pairs, now the lone pairs check off as well, and we have the correct number of bonds and the correct number of lone pairs for each atom. And then if we total up the number of valence electrons, and keeping in mind every line represents 2 electrons, so here we have 2 lines, which is 4 electrons, and here we have 2 lines, which is 4 electrons. Okay, plus 2 and 4 and 2 and 4 from this side, you'll get a total of 2, 4, 6, 8, 10, 12, 14, 16. So our final structure is a carbon double bonded to each oxygen with 2 lone pairs on each oxygen. All right, so if you ever come to a structure where you find that you're not using up all of your valence electrons and every atom has the correct number of lone pairs, but not the correct number of bonds, then you know to start adding double or triple bonds based off of the number of bonds that those outer atoms want. Now the next example, C2H6, here we're going to deal with multiple central atoms. So the first step, as always, is to determine the total number of valence electrons, where carbon has 4 valence electrons, which we saw from the last example, and hydrogen, remember, it's in the first group, so it has 1 valence electron. And here we have a total of 2 carbons and 6 hydrogens. So we've got to multiply the 4 times 2 for the 2 carbons and 1 times 6 for the 6 hydrogens. So 8 valence electrons from carbon, 6 from hydrogen, and add those together to get a total of 14. Okay, so we have 4 valence electrons. Now we need to determine the central atom, which we know can't be hydrogen. But the problem is that we have 2 carbons. So which one is the central atom? And the answer is both of them can be the central atom. And so what we're going to do this time is place the 2 carbons side by side. And so we have 2 central atoms in the center of our structure. And then we want to arrange any of the remaining atoms, our hydrogens, around those carbons. And if I start going clockwise, on the top of this carbon, I can have a hydrogen, on the right and on the bottom. But I cannot place a hydrogen to the left of that carbon because there's already a carbon there. So next, I'll place a hydrogen underneath the carbon on the left, and then on the left of that carbon and on top of it. So notice how each carbon can only have 3 hydrogens instead of 4 because the carbons themselves are going to bond together. Now, the first single bond that we want to form is between the central atoms. So we're going to place a single bond between those 2 carbons. And then we're going to place single bonds between the carbons and their corresponding hydrogens. And remember that carbon can only have 4 bonds. And so the carbons have already formed a bond between them. And then each carbon can form 3 more bonds to 3 hydrogens. Okay, if we check the total number of valence electrons that we've used, it's 2, 4, 6, 8, 10, 12, and then 14 for the 2 in the middle. So we've used up all 14 valence electrons. Remember that hydrogens and carbons both should have 0 lone pairs. And so our final structure has the 2 carbons bonded together and 3 hydrogens connected to each carbon. Okay, one last example. This time, we're going to add an oxygen into the system. So we have 2 carbons and 5 hydrogens, and then an oxygen and a hydrogen at the end of that formula. So the total number of valence electrons, we have to account for the carbons, hydrogens, and the oxygen. Carbon contributes 4 based off the periodic table. Hydrogen 1, and oxygen 6. Okay, we have a total of 2 carbons, and there's only 1 oxygen, but the hydrogens, you've got to make sure that you count up all the hydrogens. So there are 5 here, but there's also 1 on the end. Okay, so we've got to add the 5 plus the 1 on the end for a total of 6 hydrogens. And then if we add all of that together, we should get a total of 20 valence electrons. Okay, once we determine the number of valence electrons, then we have to figure out what the central atom is, remembering that hydrogen can never be the central atom. And so we're picking between carbon and oxygen. And carbon is farther to the left, and therefore we want to make carbon the central atom. Okay, so I start off like last time. And then remember, when we arranged those remaining atoms around the central atom, there was a tip that said to save the hydrogens for last. And this is where that becomes important. So the only other outer atom that we have is an oxygen. I want to start with that oxygen. And it doesn't matter which carbon that I place it on. So I'm just going to place it on this carbon on the right. And then after that, now I can start adding my hydrogens to my carbons, keeping in mind that carbon can only have 4 bonds. Well, the carbon on the right, already has a bond to a carbon and to an oxygen. So that carbon, if it can only have 4 bonds, can attach to 2 hydrogens. And now it has a total of 4 bonds. The other carbon on the left only had a single bond to another carbon, and therefore it can have 3 hydrogens. Okay, well, if we count those hydrogens up, right now we're looking at 5 in the structure, but we have this extra hydrogen on the end of the formula that we haven't accounted for. And we can't attach it to the carbon because we cannot exceed 4 bonds to either carbon. And so the only place left that we can attach that hydrogen is onto that oxygen. So oxygen actually becomes a 3rd central atom with 1 hydrogen attached to it. Okay, so after we formed our single bonds to all our central atoms, and we saved hydrogen for last and attached it to the oxygen, now we want to count up the total number of valence electrons and see if we have any left. Okay, we used up 2, 4, 6, 8, 10, 12, 14, 16. So we've used up 16, which is less than that 20 by about 4 electrons. And if you think about the lone pairs, well, carbon and hydrogen should have 0 lone pairs, but oxygen typically has 2 lone pairs. So that accounts for the additional 4 electrons. And then that becomes our final structure where we've used up 16, 18, 20 total electrons. So the carbon is attached to 3 hydrogens on the left, which is attached to a carbon with 2 hydrogens, the oxygen, and 2 lone pairs on that oxygen.